Hello viewers and welcome to yet another episode of Video Geek YouTube series where we discuss the latest education topics to increase and enhance your knowledge. So our today's discussion of topic is VLAN configuration, which is related to networking, and everyone knows that topic related to networking can be carried out by the showing the sequence of commands that we can enter on any networking device. But that's not how it actually works. First of all, we need to carry out the discussion on the topic, that what is the need of topic and why this topic has been introduced in the networking, and then we can carry out the configuration that we do by typing commands. So the this way, by carry out the discussion and then the activity, or you can say the sequence of command that you are familiar to do, so this step of sequence will be beneficial to all. So let's start the discussion on today's topic. So these are the topics that we'll be seeing today. First of all, we'll see what is VLAN, then benefits of VLAN, then what are the distinguishable types of VLAN, and we'll end this discussion by CPT activities such as VLAN creation command, VLAN port assignment commands, and other important commands. So let's start the today's discussion. Virtual LAN, or you can say VLAN, or virtual local area network. As its name suggests, it is virtual, which means it is a logical separation. So as we all know that switches are layer 2 devices. So, the functionality on such layer 2 devices, which provide the segmentation and organizational flexibility to the network administrator, which is called VLAN. So, in VLAN, we generally doesn't bother about the physical location of the devices. You can see that in the figure shown here, you can see my pointer, and you can also see that the devices which are in VLAN 2, these devices are in VLAN 3, and these devices are VLAN 4. Accordingly, having their role assigned as IT, HR, and sales. And you can also note down the network that on which they are operating and the subnet. So that's the logical details, but you can observe the physical location of that device, that all IT devices are on different floors, first floor, second floor, and third floor. So that's the beauty of VLAN, that we can extend the virtual network up to any physical location that we want. Just we want is logical separation, not the physical separation. So that's the beauty of VLAN that it provides. So we'll further carry out the discussion more on the VLAN. So let us talk about the benefits of VLAN. So first benefit it provides is smaller broadcast domain. As you all know that as we connect the switches, as we extend the switched network, so the layer 2 broadcast domain will be increased. But as we use the VLAN, we separate the each port to be assigned on the different VLAN, and the devices which are on the same VLAN, they can only broadcast their, you can say, frames onto the same VLAN on which they are currently exist. Which means you can observe the figure over here. If the faculty PC, which has assigned the IP 172.17.10.21, if if PC1 broadcasts the frame, then only the devices which are in VLAN 10, such as this PC, will only receive the broadcast frame. Other PCs such as PC2, 5, 3 or 6 will be not receiving the broadcast frame because they are not in the same broadcast domain. So that's how VLAN separate the, you can say, VLAN separate the broadcast domains by separating logically, which means different VLAN will be having different broadcast domain. The second feature it provides is improved security, which means you can say that even if VLAN 10, which means the PC1 forward the broadcast frame, then only the PC which are currently in VLAN 10, they only receive the frames, which means the devices which are on the same VLAN they only able to get communicate with each other. So that's how it also improves the security of a network. The third and most advanced benefit that VLAN provides is better network performance. As you know, as you can see over here, that the first benefit was smaller broadcast domain. As in the switch network, there are smaller broadcast domains, which means the if we forward the frame in the network which have the larger broadcast domain, then we can see that the broadcast frame will goes into whole network, and that's how the network performance will be down. But as we have configured the benefits of the VLAN, as we have configured the VLAN successfully, then we will have the smaller broadcast domains, so the frame will not be broadcasted into whole network. Only the devices which are in the same VLAN they only have the broadcast. So that's how it also provides a better network performance. So these are some benefits of virtual LAN. So now we'll see the types of VLAN, the observed types of VLAN, or you can say the types of VLAN based on some characteristics that they have or they consist. So first type is default VLAN. As you can see the output of the command which we have entered on the switch, the privilege executable mode, the command is show VLAN brief, which intended to show the VLAN and the ports assigned to each VLAN. So you can see by default all the ports of the switch. The switch which we have used over here is 2960 switch, the catalyst Cisco switch, which you can see the output of this command shows the default VLAN's name. The ID of the default VLAN is 1, and which is having currently state active, and all the ports are assigned to this VLAN. So this is the basically default VLAN that we can see configured by default on the Cisco switches. So by default all ports are in the same VLAN, all ports are in the default VLAN, which is why all ports are able to communicate. So there are also several characteristics of these ports, that the native VLAN is VLAN 1 by default, the management VLAN is VLAN 1 by default, and default VLAN cannot be renamed or deleted. So that are the some characteristics of the default VLAN. So let's move to next type of VLAN. So the next type of VLAN is native VLAN. So as you can observe this figure that we have also seen the previously, so you might notice the link between the network devices between two switches. Actually this link that is highlighted over here, or you can also consider this link if you can able to see my pointer, then they are called trunk links. Why trunk links? Trunk link because the different types of VLAN which are configured in this switch and also which are configured in this switch, if they want to go from this switch to this switch, then they can use this single link which is connecting two different network switches. So as you can observe the role of trunking, that it allows the multiple VLAN Ethernet frames, like from VLAN 10, if someone want to send the a frame to VLAN 10, but it is actually in this switch, which means it is connected to this network device, so they can use this switch, this link which is trunk link. And if VLAN 10, the end device which is currently in VLAN 10, if PC5 wants to send to frame to PC2, then also they can use this link. So the link which allows the transformation of multiple VLANs from the same link, that is called trunk link. So actually to manage this trunk link, we must need to configure the native VLAN. And native VLAN means the common VLAN which exists between this switch and this switch, because it is possible that we have not configured VLAN 10, 20 or 30 onto this switch, but in order to transfer, you can see in order to successfully transfer the frames from this network device to this network device, there must exist a common native VLAN, or you can say a common VLAN between these two switches. So in order to configure a trunk link, we must have some native VLANs which are commonly existing between these two switches. So that's called native VLAN. We'll furthermore discuss on this native VLAN and trunk links in upcoming videos. But that's all for it now. Let's move to next type. So the next type of VLAN which we'll see is data VLAN. So these are the VLAN which are created by the network administrator to separate the user generated traffic. So as you can observe that VLAN 2, 3, 4 given in this figure, if you can able to see my pointer, that they all are data VLANs, which means they are configured manually by the network administrator, and they have served the purpose to separate out the user traffic, or you can say user generated data traffic on the network. So that is basically data VLAN. So the next type is basically management VLAN. It is also a one type of data VLAN, but it is configured manually by the administrator for some specific purpose of the management of network, which means if we want to manage a network remotely, then the traffic called or you can say the network traffic which requires to manage the network remotely are SSH, or you can say HTTP, HTTPS, or telnet or something else. So these all are configured by, or you can say configured in management VLAN. And the next, or you can say last type of VLAN is voice VLAN, which means the devices which supports VoIP, which means voice over IP network traffic, they need to have, or they must have separate VLAN configured for their data traffic. So these are basically the observed types of VLAN based on their individual characteristics. So let's move to next topic. So we have covered all the theory discussion that are required before going on to VLAN creation commands. So these are the sequence of commands that you need to enter for creating a VLAN on Cisco switches. So we'll demonstrate the commands in the CPT. So let's get started. So we'll configure the VLAN by, first of all, we'll see the VLAN creation commands. As you can see the topology, the logical topology, as I have taken two PCs for student lab, two PCs for faculties, for teachers. You can assume that this is some school and we need to provide network to student lab, to faculties, or you can say in the staff room, and there is some network management lab also. For that also we need to have separate VLAN, such as VLAN 30 or something else. We have taken VLAN 30, and these are the network IDs for configuring, or you can say for having a VLAN 10.10 having /16 subnet mask on for the students, 10.20/16 for faculty, 10.30/16 for management. First of all, we'll provide the IP to all PCs. 10.10.1, this will be having 10.10.0.2, and subnet mask is 255.255.0.0. This will be having 10.20.0.1, and subnet mask is /16. This will be having 10.20.0.2. Let me just re-verify that what I have entered. Okay, that's correct. Now 10.30.0.1, and the subnet mask is 10/16. Now over here 10.30.0.2 and the subnet mask is 255.0.0. Now as you can see, we have configured the IP in all the devices. Now we need to connect it through the switch. So let us actually take the quick wiring over here. Not quick, will go line by line, which means fast Ethernet 4, 6 will goes over here and 5 will goes over here. You need to actually remember the you need to actually remember the port on which the devices are connected. These two devices are connected on fast Ethernet 1, 2. These two are connected on 3 and 4. These two are connected on 5 and 6 respectively. Now we need to create the VLAN. In order to create a VLAN, first you need to go to global configuration mode. As you can see, we have already in the global configuration mode by observing the prompt S0 and config in brackets followed by the hash. Now we'll create a VLAN. In order to create a VLAN, you can enter a VLAN command, and if you hit space and question mark, you can see it is asking for ISL VLAN IDs, and you can see it says you need to enter between 1 to 1005. So we have configured logically that we need to create 10, 20 and 30. So first of all, let's create VLAN 10. As I have entered VLAN 10 command, it also goes into VLAN configuration mode. Now we need to give name to this VLAN, right? So in order to give name, we can enter name, and then if we hit space and question mark, then you can see it ask for word, the ASCII name for the VLAN. Let's give students, and as I enter the exit, the VLAN is configured successfully. So following the three same steps for other two VLAN 30 and 20, let's create the so for creating faculty VLAN, we need to enter VLAN 20, then name faculty and exit. Now for management VLAN 30, name management and command exit. Now we can also enter end, and we can first of all save the running config into startup config. And now if we observe, so we have successfully created, as you can see, 20, 30, 10, 20 and 30 VLAN, which has the name students, faculty and management. But there are no ports assigned to VLAN, each VLAN, and all the ports are by default in the default VLAN, which is having the VLAN ID 1. So we have successfully learned the VLAN creation commands. As we have learned the VLAN configuration command, or you can say VLAN creation command, now we'll see VLAN port assignment commands. They are described over here, but let's see in the Cisco packet tracer. So previously we have created the VLAN successfully. All VLANs are configured, or you can say created successfully. You can observe the output of show VLAN brief command in the privilege executable mode. But since there are no ports assigned to it, we need to assign a port to some specific VLAN. So for the ease of getting port assignment, we have configured these two devices on fast Ethernet 1, 2, these two on 3, 4, and these two on respectively 5, 6. So let us first of all enter the global configuration mode. For that we can enter configure terminal command because we were in privilege executable mode. Now we need to actually uh, go ports by ports. If the ports are not in contiguous order, then we can go for interface fast ethernet 0/1, and then we can enter switch port mode access, switch port access VLAN, and the VLAN ID that we want the port into B. So fast ethernet 1 is connected to PC 0, and we can give it to enter in, or you can say go in VLAN 10. So the command is switch port access VLAN 10. If we hit enter, then you can see this green blip was now converted to amber. It will converted in green again after some time. As now we have configured this port to be in VLAN 10, we can now exit. Now same for interface fast ethernet 0/2, switch port mode access, switch port access VLAN, and the VLAN ID is 10. So you can also see that this blip is converted to amber, and this blip is now converted to green again. So that's how we can go port by port and assign VLAN to each port. Now if the ports are contiguous, which means if these ports, suppose they are in uh, actually they are in contiguous order, which means PC2 is in fast ethernet 0/3 and PC3 is in fast ethernet 0/4. So we can also hit the command like interface range fast ethernet 0/3 starting port, and then hyphen, and then ending port, which means 4. So you can see we have entered in configure interface mode, but it is in range. Now we can enter same command, but the you can say the catch is we only need to enter the commands only once. Switch port mode access, switch port access VLAN 20. As I will enter this command, you will observe that these two green blip will be converted to amber. See, and now we can exit. Similarly, we can go for VLAN 30, interface FA 0/56. Okay, I forgot to enter range over here. Now switch port mode access, switch port access VLAN 30, and then we can exit. We can also end. Let us copy the running configuration to startup, and if we now enter the show VLAN brief command, then you can see that now the VLANs are also created and the ports are also assigned to them. The previously fast Ethernet 1.2 was in the default VLAN, now they are in 10 VLAN as we have entered the command for it, and successively each port that we wanted to move to specific VLAN. So now in order to verify that they are separated or not, we can go into simulation mode. And as we have seen that it separates, or you can say it creates the smaller broadcast domain. So the device is the device, if you can see the PC0, if it forwards the broadcast domain, then it will also, or you can say it will only goes into PC1, which means it will not be forwarded to any other VLAN. So let's try that. So that's the ARP request, by the way. If you observe the packet, see, MAC address, the broadcast address or multicast address, ARP frame, ARP process it's. So it is a echo ARP echo response, or you can say echo send, and you can see it is only forwarded to PC1, and now the communication happening and the ping is successful. If we want to communicate to different VLAN, then see then let's see what happens. It directly drops the frame, and this is the BPDU package, or you can say BPDU frame. That's not the echo frame or the frame which was sent by the PC0. So that's how we can create the virtual network, and we can assign the ports to it, and we can have separate smaller broadcast domain. As you can see on the screen, as you now understand the topology, and you can see we have configured VLAN 10, 20, and over here 2010, and there are two separate links, fast Ethernet 5, which is the port fast Ethernet 5 on this switch is in VLAN 10, and also the fast Ethernet 5 on this switch is in VLAN 10, and similarly the fast Ethernet 6 on both the switches is in VLAN 20. Now suppose the VLAN 20 from this switch wants to forward the you can say the packet in this switch. You can see the VLANs are same, so it can have communication, but they are on the different switches. So if he wants to forward the frame, so let's see how the communication goes. So you can see first it has sent the frame, which is sent via this fast Ethernet 5 link, because the link was in VLAN 10 and the traffic was coming from the VLAN 10 itself. If in between VLAN 20 device, which means PC1, if it wants to communicate to PC6, let's see which links this packet will follow. So you can see the packet was broadcasted, but it has only broadcasted to links which are currently was in the VLAN 20, which means that this fast Ethernet 6 link and this link. And also this switch will forward this to this packet which is coming from VLAN 20 to the links which are connected to VLAN 20 itself. You can see. So this why you can see if there are multiple VLANs. So in order to get communicate with uh, another switch, or you can say the similar VLAN but they are on the different switches, we need to have n links to be able to communicate with n VLANs. So that's why the concept of trunking is used. So in upcoming videos we'll see the need of trunking and how we can configure the trunking. So that's the actually hint for upcoming lectures that you may see in the future in this YouTube series. So subscribe to channel if you want to get updated to latest education topics. So that's it from today. So we'll see in the next video. Till then, keep learning and keep exploring.